India is home to the largest number of blind people in this world. Out of 39 million blind people in this world, 15 million are from India. For blind is of utmost importance for the overall socio-economic development. The education for blind has seen evolving approaches in the recent times. The most useful device that the Braille students can use for reading is the Braille note taker, which has refreshable Braille characters. This gadget is a portable substitute for Braille books that were developed about 2 centuries ago. Braille note takers, however, expensive, costing about $5,000 per device. Most of the Braille note takers are multifunction, handling word processing and calculator services, just to name a few functions. Therefore, if a student needs a Braille basic calculator, for example, they have to buy the whole Braille note taker device. The reason why there are no single operation dedicated Braille devices is that actuators used to drive the Braille pins in the characters are piezo polymers, which are costly. Since the piezo actuators are costly and longitudinal in structure, they cannot be used to make full-page Braille display for graphics. As an alternative to piezo polymers, in our project we make use of mechanical cam follower assemblies. The mechanical cam follower assemblies can be made to have circular profile, which can be used for making full-page Braille displays. Our project is implemented using 2 parts, namely the programming part and the mechanical part. The prototype is shown below. It consists of the beagle-bone black, and the mechanical part is implemented using solenoid actuators. The prototype for the solenoid actuators is shown using LEDs. The beagle-bone black was given to us by the Texas Instruments. Our aim of the project is to convert the text file to the corresponding Braille characters. The text file is given to the beagle-bone using an external storage device. Once the beagle-bone detects the external storage device, it converts the text file to the corresponding Braille characters. Now we have used a pen drive. In the place of pen drive, we can also use an SD card. We also have the other components, the switch which is used to control the overall device. Once it is on, it will automatically start reading the text file and converting it to Braille characters. We also have a potentiometer to control the delay time, which is given to IDC pins. We also have a panel of LEDs which is used in the place of solenoid actuators for the prototype, which is given to GPIO pins. For the mechanical part, we are using the solenoid actuators, but for the prototype, we have shown it using LEDs. The mechanical click pens use a cam and follower assembly that is made up of 5 basic parts: the groove, cam, follower, spring and pin. The parts function together to form a manually toggled system that has 2 states. The groove is designed to hold the rest of the pieces. The cam pushes the follower, which depending on the assembly's current state rotates to a resting position that places the pin in a high or a low state. The spring ensures that follower slides into the high and the low grooves every time the cam is active. Using cam followers, each Braille pin that has this assembly below it, which is driven by a stock solenoid. According to the Center for Braille Innovation, under loading such as the touch of a Braille reader's finger, a pin should provide at least 20 grams of lifting force and have a vertical depression of less than 0.1 mm from its top height. The cam follower approach meets this requirement by having the follower resting on the on-state grooves and locking in place until it is pushed by the cam, making it possible to move it down even with a force many times greater than 20 grams.
The major part of the project is the programming part. The program code is built using Python 2.7.6. Now I am going to explain the programming part of the project.
Now coming to the programming part, first we import the external libraries to the program. The selected portion indicates the external libraries which is used in this programming part. This selected part are the major library used in this programming part, which help to access GPU and ADC pins of the beagle-bone. Now we define NAM function, which detects external storage and return path of the text file. The OS and RE libraries are used in the NAM function. Now we define a function for the Braille code of A to J, which is similar to the Braille codes of 0 to 9. Now we define a speed function which is used to adjust the speed of character change. It is done by reading the resistance value from potentiometer connected to ADC pin in the beagle-bone. Now we reach the main function, Here we set the GPIO pins as output or input. Here we define the Braille characters of each letters from A to B.
This is the programming part of the project. Next we are going to watch the working of the prototype.
To turn on the beagle bone, we connected it to a supply of 5 volt. The supply can be provided either by USB cable or 5 volt adapter. Now the beagle bone is turned on. To provide text files to beagle bone, we can use a pen drive. As we said earlier, we can also use a SD cards as input. The program is now running. The code is saved as a script and it is saved such that it will automatically run whenever the beagle bone boots. So we doesn't need the use of laptop after coding. We can adjust the speed using potentiometer. Whenever the resistance is low, the speed is high, and if the resistance is high, the speed is low. We can make a maximum of 2-second delay in the circuit. The switch is provided to on and off the circuit.